A very good morning, class. Today we'll be talking about the C section, that is separation of liquid-liquid mixtures. So a mixture can be a homogeneous mixture as well as it can be a heterogeneous mixture. Now homogeneous means liquid which dissolves in each other completely and you cannot make out that which one is what. That means completely mixed. So that is homogeneous mixture, whereas heterogeneous mixture is what? Liquids which do not dissolve in each other are called heterogeneous mixtures or immiscible liquids. Okay. Now, how can you separate those liquid-liquid mixtures? So there are various methods. First is by separating funnel. It is a simple device that is used to separate the components of a liquid-liquid heterogeneous mixture. Liquid-liquid, both are liquid but heterogeneous. That means they do not dissolve in each other. So like an example of kerosene oil and water is given. In the figure you can see this is a structure of separating funnel. In that you will add the mixture in the separating funnel and you will allow it to stand for some times. The component forms two different layers. Water being heavier forms the lower layer and oil being lighter forms the upper layer. And when the stopper of the funnel is opened, the heavier liquid trickles out slowly. It gets down slowly and is collected in one vessel. And then you immediately close the stopper. Then again you put on the stopper and the entire oil that is above the water will be collected in another container. Okay, so this is how you separate a liquid-liquid heterogeneous mixture. We'll be talking about separation of two homogeneous liquid-liquid mixture. That means where the liquids dissolve in each other complete. So how you will differentiate between them? So the difference can be find out only on the basis of the boiling point. Okay, when you heat the mixture, the boiling point decides what are the components in that mixture and at what temperature they will evaporate. So an example is given in your book, that is a mixture of water and alcohol. Alcohol boils at lower temperature than water. So what happens? The vapors of alcohol are collected and cooled while water is left behind in the flask. For the example you can see in the figure given, you have a burner from which you heat the solution of alcohol and water. There is a cork or stopper in which extra moisture is not allowed to enter. Okay, then you have a thermometer which will calculate the temperature, and you have a cork in which you will see the vapor start emerging out. Then that cork is connected to a water condenser. I have already told you about Liebig condenser. This is water condenser in which continuously cool water is flowing. And then because this vapors has to be converted into liquid, that's why the water condenser is there. And then water is collected or the liquid is collected in the beaker. So this is how you collect a liquid-liquid homogeneous mixture. Now, once alcohol has been evaporated, at 100 degrees centigrade, water will evaporate. So you will collect it in a beaker. Okay. Then there are certain modern techniques that are used in our day-to-day life. Okay. Like these are very common and prevalent techniques. There are certain modern techniques that has been added in the separation. So one of the common modern technique we'll be studying today, that is your chromatography. Now, what is chromatography? Chromatography is a series of analytical technique that can be used to separate the mixtures of compounds for further use of analysis. Now, in very simple word, the process of separating different dissolved constituent of a mixture by their adsorption on the appropriate material is called chromatography. Okay, there are two terms to be noticed: adsorption and absorption. It works on the principle of adsorption, that means surface absorption. Okay, now the common adsorbent that is used in this technique is filter paper and silica gel. Okay, and the solvent in which you dip this paper is water or ethyl alcohol or acetic acid. Okay, now paper chromatography we'll be talking about. In this, know what are the principles involved in chromatography. Chromatography separates the components of a mixture on the difference of two phases present in them. Okay, so we'll be talking about paper chromatography. So there are two phases in this. First is stationary phase and second is mobile phase. Now what is stationary phase? The phase that does not move, that means it is fixed, and the compound in the mixture are attracted to the adsorbed and slowed down, either solid or liquid. Second one is mobile phase, that moves. Okay, in this method a special type of paper called chromatographic paper is used. That paper is also known as Wattsman filter paper. Why? Because this discovery of paper chromatography was done by Wattsman. Okay, now a line is drawn with a pencil near the bottom edge of the paper. When you will see the structure of paper chromatography, that is in the next slide, you will have a line. Can you see? Okay, now this line is a line made with the help of pencil. Clear? And a drop of mixture is placed on the filter paper above this line. As you can see, the ink spot is kept over water. Okay, and then what happens? The paper is dipped in a solvent taken in a beaker so that the line drawn on the paper starts moving in the mobile phase, and the filter paper acts as a stationary phase. The filter paper does not move, whereas the mixture that you have put it, suppose you have a ink spot, that will start moving up. So the solvent rises on the paper. It takes along it the drop of the substance. Now the component of the drop which is more soluble rises faster, and we see various spots on the filter paper, each indicating a component of a mixture. The paper is then removed and the solvent is dried. It's a bit confusing but very easy. Suppose you have a ink and you have included in that red color, yellow color, blue color, all the colors you have mixed, so that ink became black. Okay, now you use this paper chromatography and you put that spot there. So what will happen? The drops will be formed at various levels. So okay, so more soluble one will rise further and the less soluble ones will be down. So you can see a clear colors and you can make out all these colors are used in this drop. So this technique is very prevalent and is very useful in the forensic science these days. We'll talk about advantages. So a very small quantity is required to see what all is there in the drop, right? Then the component with very similar physical and chemical properties can be separated, right? And this can be used, when we talk about uses, it can be used to separate various natural colors pigment. It can be used for pathological test. I've already told you, like a person has died or has done a suicidal attempt, so his blood sample may contain certain drugs, so that can be made out ki okay, in this blood this was the drug used by the person. So all the forensic reports, you see the autopsy reports and all also can be made with this chromatography technique. So this technique is very important. Then you have an application or uses. It can be used for I told you pathological use. It can be used for analysis of drugs and vitamins. It can be helpful in the differentiation of complex mixtures. Then we'll talk about if the separation of constituents of mixtures are there with more than two constituents, like you have three constituents in it, how will you separate? Suppose you have a mixture of sand, sawdust and salt. So what you will do, you will take the mixture in a glass beaker and you will add water to it. Now what will happen? Salt will dissolve in water. Sawdust, being lighter, will move on the water, will float on the water, and then sand, being heavier, will settle at the bottom. So you can use the process of sedimentation and decantation, or you'll do what? You will take salt solution along with sawdust and you'll pour it slowly in the filter paper. Okay, now the solution passes through filter paper and the sawdust remains in the filter paper. Sand is left in the beaker as sediment. Sand is separated, sawdust is separated. Now how will you separate salt? You will put that water content in the evaporating dish and you will allow it to heat. Water will evaporate, leaving back your sand. So this is how you separate a mixtures more than 3 in number. Then another example is your iron filling, sulfur and common salt. You know very well, if you bring a magnet, iron filling will get attracted towards it. When you pour water into the content, salt will mix with it, whereas sulfur will not mix it. Sulfur will be left behind. Then through filter paper you can take out sulfur, and then through evaporating dish you can get salt back, and iron through magnet you have got. So this is how you separate a iron filling, sulfur and common salt, more than 3 components. So with this I complete the chapter, and exercises we'll be doing in the next video. I hope this video was fruitful to you. Keep watching, stay healthy and safe.